If the body scanner uses infrared cameras, what are the key hardware components that are essential for safe, accurate and reliable body scanning? This is another crucial question to consider when investing in a body scanner. It is now clear that the future of mobile body scanning is to use infrared cameras, which will give the client a more holistic set of metrics, and in turn give the client and the coach more data to make informed decisions. Having administered over 15,000 3D body scans, I've learned that there's some very important setup and hardware requirements for successful, accurate and reliable 3D body scanning. If you take a step back, they all make perfect sense. Most images and data gained from a 3D infrared body scan are extracted from the 3D image. So the ability to create a high quality 3D image is essential. So that being said, what enables you to create a high quality 3D image on an infrared 3D body scanner? The four most important hardware considerations are: number one, that the machine has fixed machine handles. Fixed handles or handles in general on an infrared body scanner are absolutely essential. Infrared technology relies on you to stand still throughout the whole process. If you do not have fixed machine handles and fixed feet, then more movement can occur during the 3D body scan, and therefore you will not be able to gain accurate girth measurements and other measurements. Fit 3D body scanners have fixed machine handles that the client will hold on to throughout the scanning process. Whilst you consider that for a moment, try holding your arms out to the side for 1 minute without fixed handles. Do you really think if a machine does not have fixed handles that your clients will be able to keep their arms and upper body dead still throughout the whole scanning process whilst the weight scale rotates beneath them? If your client's arms and upper body are not still throughout the whole scanning process, then it can lead to a distorted image, and therefore you're likely to gain larger circumference measurements and a blurry 3D image. Having fixed machine handles also allows the client to be more stable whilst the machine slowly rotates beneath them. This will stop clients falling off and you needing to retest clients all the time. The second piece of essential hardware is you must have 3 infrared cameras, not 1. Ask yourself, what is likely to be more accurate, a machine with 3 or a machine with 1 infrared camera? Fit 3D body scanners now have 3, not just 1 infrared camera. These cameras take hundreds of photos of you during one 35-second scan and generate the most accurate 3D image available. It's got to a point where we can now see the outline of bones, your veins, strands of hair and the outline of muscles. The problem with only 1 infrared camera is that more knitting or guessing is required to join all the different data points together. Then you're less likely to get an accurate 3D image. You'll notice if you look online that 3D images generated with only 1 infrared camera will be less refined and therefore less likely to be as accurate. The key point here is that the smaller the amount of infrared cameras, the less likely the 3D images to be accurate, and thus the more error that can occur during every single body scan. The third essential piece of hardware is a connection that allows you to stand at a fixed length away from the vertical tower, the tower that holds infrared cameras on it, every single time you scan. Again, ask yourself, how can you get a reliable comparison if you don't stand the exact same distance from the vertical cameras every single time you scan? Especially when accurate body scanning relies on you to be in the same position in the same conditions every single time. Imagine you're taking a photo for a friend of your friend that's 1 metre away versus 10 metres away. Clearly these two photos are going to be quite different. Infrared cameras, although completely different, the concept is exactly the same. If you stand at different lengths away from the camera tower, then there's no way you'll be able to get reliable comparisons on rescan. Fit 3D body scanners have footprints on the weight scale base. This, combined with a key connection piece that connects the vertical tower to the weight scale base, ensures that you stand at a fixed length away from the scanning tower every time you scan. The fourth key hardware component is the turntable The weight scale must rotate at a constant, controlled speed throughout the entire scan, including the acceleration and deceleration phase. Uncontrolled acceleration and deceleration are one of the key reasons why some of the knockoff 3D body scanner brands get blurry or distorted images, because that process isn't smooth. The geniuses behind the Fit 3D system have integrated a feature that controls the acceleration, deceleration and in-scan speed throughout the entire 3D scan process. This, combined with using 2 fixed handles, 3 infrared cameras not one, allows the user to gain an accurate 3D image when using Fit 3D and therefore comparable results every time you scan.